Nuclear chemistry balancing nuclear reactions worksheet. Now on the far right it says types of nuclear reaction. Really they should have had two columns instead of one for natural or artificial transmutation, because the reaction is going to be one or the other. It's not going to be just blank. So they have artificial transmutation, but if it's not artificial then it's going to be natural. Now up here on the board, Amir, you should be writing this down as far as notes because you could see it again on Friday on your quiz. Now up here, artificial transmutation, it says all of these equations have two reactants. That's kind of the signal for you. If you see two reactants, then you know it's going to be artificial transmutation. They're forcing this helium, into your aluminum artificially. You're forcing this neutron in there, and so forth. So artificial transmutation always has two reactants. So it's pretty simple. If you get one, obviously natural is going to have what? One reactant. Very good, Elijah. So that would be beta absorption, and it would be artificial transmutation. Yeah. This is obviously beta capture because it's capturing the photon, absorbing it, thus changing the photon into a neutron. So the neutron is basically still here because remember the neutron is 0, 1. So you've taken away one of the protons and you've made a neutron, so it's being absorbed or captured in the nucleus. Alpha decay. And is it natural or artificial transmutation? Very good. So we're doing this one right here, right? Yep. All right, so you have a neutron that's being emitted, right? So you have, what's 99 plus 2? 101. It's like over there. All right. And then you look on the periodic table to find the symbol. And what's 253 plus 4? And then minus 1. 256. So that's the mass. So you go to the periodic table to find. Our star, Earth, their sun. Raise your hand, think it's going to form a black hole. Y'all are smart. Raise your hand, think it's going to form a supernova. Okay, close enough. No, it's going to form a what? It's going to form a black dwarf. I know. You should have seen this before. You should have seen this in like biology. They usually have. You didn't do less in biology?
It's simply copying
Never do.
We have this
Stop saying it.
Alright, so before our star turns into a black dwarf, what's it going to do? What's it going to form? I know. What's our star going to form before it turns into a black dwarf? It's going to form a red giant. Very good. Gas and dust. Raise your hand if you think gas and dust. Well, you don't have a lot of followers. Oh, Summer's one follower. Anybody else? What do you need in order for a star to form? Yeah, you need temperature, high temperature, and a pressure. Write that down. Trayvon is correct. Those are the two things needed for star formation. Where does the heat come from? Does it come from burning methane or burning coal? Raise your hand, burning methane. Raise your hand, burning coal. No, don't come from burning methane or coal. Come on now. I'm talking about in the outer space. Burning would require oxygen. So this is a fusion process. So where is the heat coming from? You're ever cold, what do you do?
Nobody does that. We have to turn up the temperature.
You don't do this?
Thank you.
What does this create? Friction, write that down. So friction, see, I didn't even tell you the answer. You can figure it out yourself. Friction is where the temperature comes from. The hydrogen atoms are bouncing off of each other, creating friction. And where does the pressure come from? Gravity. They're pulling together. Like if you go swimming, the further you go down, the higher the pressure. So how can there be different sized stars? How do you have like a small star and a large star? Time, write it down, time. There's a set amount of time it takes for the star to ignite. So over a period of time, the friction is going to create higher temperatures, and then eventually it's going to ignite associated with the amount of gas that's there. Once a star ignites, can it gain more hydrogen? No. It'll be then pushing it away. The star is going to be burning and putting off energy. That's going to be a resistant to the hydrogen coming in there to make it larger. All right, very good. So let's read on a little more. The sun, of course, the star will now begin to shed its outer layers. All right, Aiden. Dwarf, right? What can eventually happen to it? Now remember, our sun could place 1 million Earths inside of it. So it creates a fairly large target. So if you're a large target and you're in space, what can eventually start happening to you? Things can start to hit you, break you apart. If you look at the moon, I mean, the moon has a lot of craters on it, so it's thought that our Earth was hit by an object and created the moon. So there's some people who think that. Does our sun affect the ocean's tide? Or is it just the moon? Oh, the sun affects it too. So the gravitational force of our sun is relatively large. Could the Earth survive without our moon? Probably not. The tides do a pretty good job of doing what to the ocean? Cleaning it. All the crud gets removed in the beaches, and the little animals eat it up. Otherwise you'd have all sorts of dead organic matter in the ocean, and you'd have pond. You ever seen a pond that's just sedimentary? It kind of doesn't support life very well. So we see up here that the Earth moon, right, is larger than Pluto. This is important to understand because a lot of people don't believe Pluto's a planet, right? So Pluto is smaller than the Earth moon. The question is Earth 1/16th, 1/32nd, or 1/64th the size of Earth? So is our moon 1/32nd? Raise your hand. 1/64th? 1/16th? Don't know? It's 1/4. So it's about a quarter.
They cute, aren't they?
Stop.
He already taken.
And then 84 right here. And then P-O, capital P, lowercase o. And then 214 right here. And then 82 right here. And then capital B. Okay. Capital B, I mean capital P, lowercase b. And then plus, put a 4 right here.
Star. Like they're saying that our star is going to form a red giant, and then it's going to form a white dwarf, then it's going to form a black dwarf. How do they know this? Anybody? Yeah, if you look at human beings, you can take pictures of them as an infant to adolescence to teenager to young adult to old age, so you can line up what they look like. So you can take a similar star and just progress them. There are a lot of stars out in our Milky Way. There's like billions of them. And that's how you do this. You just figure out which stage they're in based on their size, and you can pretty much get a linear picture like we do with how we progress. Does that make sense? You can take pictures of how we grow. So there should be a separate column on that page, because all of them on that sheet are going to be one or the other. They're going to either be natural or artificial. 13, can anybody do 13? You can pick somebody, Sultan.
There's no number. How little the J's orange crack. Yeah.